Hello, Mr. Kitchen, Cobleskill, Richmondville High School Physics. Today we tackle the rocket problem for three reasons. First of all, interstellar space travel is something you humans know pitifully little about. Secondly, I'm not blessed with a whole lot of artistic talent. There are only three things that I draw exceptionally well: rockets, Volkswagen Beetles, and trains. So a disproportionate number of the problems we're going to solve this year will involve rockets, VW Beetles, and trains. And finally, it does provide a nice example of net force and acceleration, which is in essence Newton's second law of motion. So the problem I want to take on today, we have a 5 kilogram rocket. It's acted upon by a 59 Newton force from its rocket engine. And we're asked to find what is the net force and also what is the acceleration of this small rocket. Now I'd like you to draw two diagrams. First of all, just showing off my artistic skill, but this is a space diagram. It shows the rocket, and we have the force provided by the rocket engine right here. Next thing is a free body diagram where we're only going to show the forces that are acting on this rocket. And what we need are the force provided by the rocket engine and also the force of gravity. So I'd like you to take a moment and think about what values we would put in for those two variables. Now, as we tackle the first part of the problem, I've listed some of the given information. The mass of the rocket is 5 kilograms, and the force provided by the rocket engine is 59 newtons. The unknown in this problem is F net. We're trying to figure out how much force in excess of the weight of the rocket is available to accelerate the rocket. So what we can do is we can say F net. From our previous diagram, we saw the force on the rocket acted upward, the force of gravity acted downward, and hopefully you realize that the force of gravity is not 5 kilograms. The force of gravity is how much 5 kilograms weighs. So we have a little embedded problem that we have to tackle over here, and that is the weight of the rocket itself. The force of gravity, of course, is mass times the acceleration of gravity. We have 5 kilograms times near the surface of the Earth, 9.81 meters per second squared. So the rocket itself weighs 49 newtons. The rocket engine provides 59 newtons of thrust in the upward direction. What we're going to do is we have vectors acting in opposite directions, so we are going to subtract those vectors, and of course 59 minus 49, we end up with 10 newtons as a net force, and that's in the upward direction. The second thing we're asked to find is the acceleration. So I need to know the mass of the rocket, once again, 5 kilograms, and we do have the net force, which is 10 newtons, and I'll just put in a little note here. I forgot that 10 newtons is acting upward. We're going to try and find the acceleration, and from our reference table, the acceleration is just that ratio of the net force divided by the mass. So we have excuse me, 10 newtons acting upward divided by 5 kilograms of mass. I'm showing you the units over here. In red, we've got the kilogram meter per second squared. There's our Newton divided by kilograms, and we see that the kilograms effectively cancel out, leaving us with units of meters per second squared or meters per second per second. Of course, 10 divided by 5 is 2, and our units are meters per second per second. We'll pick up a couple more examples of rocket problems and other problems involving Newton 2 in class today.